Configure VXLAN. Hello everyone, this is NetMaven. Today we're going to talk about a VXLAN, and VXLAN provides a way to extend L2 network across L3 infrastructure using MAC in UDP. This is encapsulation and the tunneling. In this lab, I will configure all building blocks that are required for successful VXLAN implementation on my network. What I have already configured is the underlay network in this range, and I have loopback 0, loopback, and loopback. And of course, the underlay runs OSPF, okay? And I run PIM between the spine 1, spine 2, leaf 1, leaf 3, okay? What you're gonna see here is 4 servers, 2 server, 11 and 21 connected to leaf 1, and server 11 is in VLAN 100, server 21 VLAN 101, and VNI wise VNI 1000 is mapped to VLAN 100. VNI 2000 mapped to VLAN 101. Take a look. The server 12 and server 22, I have VNI mapped to 200. That is for server 12, and server 22 we have VNI 3000. That is mapped to VLAN 201. If you notice that we have the same VNI for server 11 and 12, and the VLAN are different, but they are in the same subnet range. Okay, this is what I'm gonna do the first time to make the connectivity work. Let's first configure the multicast routing. I can use one of the 2 methods to handle the broadcast. Unknown unicast and multicast. This we call the bomb traffic. This first method is to use the multicast in the underlay, which is ping here and RP. The second approach is called ingress replication, where each bomb packet transmits that unicast towards the destination. A multicast method is more efficient, as I have only 1 copy of bomb packets. Is unlike unicast replication. Okay. There are 2 ways to handle the traffic. Then we're going to pick multicast. This method works well when I have many leaf switches, so we don't have to unicast each unknown bomb traffic to all the leaves. So in this lab, I will prepare network to support the multicast forwarding. I have configured the RP router. I have to configure one of the RP here, which will be used as a root for multicast share tree. And typically I will have a configuration for Anycast RPs in leaf span topology, where all spine routers act as a RP. There will be RP, with a single IP address. This the same, of course, the spine 1 and spine 2. And Anycast RP is more fault tolerant and allow the load sharing, right? So the Cisco Nexus series switches are the spine, they are Nexus switches. A spine, they are spines and leaves, and I will enable the ping on all switches and to configure the spine as Anycast RP routers. So the IP on the loopback 1 is gonna be my RP address, and the interface and IGP are pre-configured. So let's just take a look at this. We'll have this loopback 1 for RP. Okay, let's just log on to my spine 1. Spine 1 here, I have put some pre-configured underlay. I have OSPF neighbor, I have a ping neighbor, right? I have two ping and OSPF neighbor. What am I gonna do? I have to configure ping. I have to configure my RP IP. Okay, so what I'm gonna pick is the loopback 1 IP. That's no interface loopback 254. This is not what I want. I want this. Okay. Reference to the loopback 0, and I have to advertise in the OSP and put it in the ping. So show run interface loopback 1. This is the IP I want, so I have to duplicate this, config in my spine 2. So no interface loopback 254 and copy that interface. So we both have the same IP interface 192.168.254.100 on spine 1 and spine 2. Well, I'm gonna go back to spine 1 and we're gonna do IP ping RP address, and the address is gonna be this shared interface loopback 1 IP. So take a look back at 0, and this is what we have to configure on loopback 0, right? Spine 2 is show run interface loopback 0 is used for the underlay. Underlay will have to reach the IP ping RP Anycast RP. So what I have to do, IP ping Anycast RP 192.168.254 that shares the RP interface, and we'll make this as RP. And my spine 2 is also an RP for the share interface, and show run pim. I can see this is my RP interface for all of the multicast IP, multicast address. So copy that and paste into the spine 2. I have a multicast IP ping RP Anycast address set up in spine 1 and spine 2. The RP set defines the all router that would act as an IP router. So I have loopback interface on each RP router. Let us show run interface loopback 1. That's the shared and same IP. Loopback 0 interface is configured on both the IP, right? We have is the 10.2.01, 10.2.02. This respectively for this share RP switches using ping enhancement to sync the RP information. I have broadcasted into the ping. I enable the ping on my loopback 0 and loopback 1, and also show run interface E11, show run interface E13. This all cross the same spine and leaf switch, and we have it enabled OSPF, advertised into OSPF, and enable the pin on the physical interface of my fabric. Okay, I'm bottling loopback 0 for the IP. Of course, let's take care of the leaf 1. I have IP ping neighbor, show IP OSPF neighbor. I have all the same. Now what we have to do is to enable IP ping RP address. Okay, so run pin. I have enabled this pin for RP, and go to my leaf suite. I have to do the same. I enable the ping, show IP ping neighbor, show IP OSPF neighbor. I see the neighbors on both interfaces, leaf 1, leaf 2, spine 1 and spine 2, leaf 1 and leaf 3, spine 1 and spine 2. The IP will represent neighbors, and I can show IP ping RP. I will see this ping RP interface is up for some time already, and the group ranges all multicast address. I have not configured any specific multicast group for the RP, so the RP is used for all multicast group, as you can see in here. Multicast routing table on leaf 1. So show IP mroute. I have one. Okay, I can see one entry at a moment. Later in the lab, and then more entry will appear as I will map the VNI to multicast group. So you will wait and see this. Same thing I can do on leaf 3, show IP ping RP. I have one RP listed here. The next configure is the VXLAN bridging with layer 2 VNI. It was to provide the layer 2 respectively between the server and different leaves. I must configure the layer 2 VNI. I'll go to the layer 2 VNI and 3 layer 2 VNIs. In this case, there's one. So one VNI 1000 and VNI is 2000 and 3000. Okay, this will have to take care of. This will have to provide a VNI because we'll have to map on each switch, and I will configure BGP pairing between the switches. I'll configure the VNI interface on each switch, which is used for the VTAP. Is going to be the VTAP on each switch will be VTAP, VTAP, VTAP. Okay, and we're gonna map the VNI to the multicast group for bomb traffic. You know, we're gonna use the Anycast method to replicate. Okay, to test this is what address and VLANs. Okay, the server 11 and server 12 are sharing the same subnets. Server 21 and 22 are connected to different subnets in different VNI, different VLAN on different leaf. Now, if I go to server 11 and I want to ping the server 12, I can't. The ping is unsuccessful. The goal later in the lab it will be enable the connectivity between these two servers. So there's something we'll have to enable on the leaf 1 and leaf 3. We have to feature VN management based, segment LAN based, and the feature MV overlay. Okay, I have to explain you later. Feature, no, that's MV overlay EVPN. Okay, 3 features I have to enable. The feature VN segment VLAN based commands, they will enable VLAN based VXLAN. This command will allow me to map VLAN to VNI segment. Okay, and feature NV overlay commands will enable VXLAN feature. The last NV overlay EVPN commands enables the EVPN on the switch, which will allow me to configure an EVPN address family on the BGP. So let's do the mapping. So VLAN 100 will map to VN segment 1000. Exits VLAN. I'm sorry, VLAN 100, no VN segment 100, VN segment 1000, is it? No. Okay. So VLAN 11, VN segment 2000, show run. I have the mapping correctly. Show VXLAN. You see the mapping clearly. Okay, so the VN segments, the commands will map the VLAN to a specific VNI. This mapping is locally significant, which means that I have different VLAN ID on other switches. The VNI IP ID is the only parameter that's global significant. What I have to do next, I have to feature BGP. We'll have to route our BGP to configure a little bit, right? The AS number 65000 BGP will be used for sharing layer 2 information between the leaves, and I configure neighbor. My leaves 3 show IP interface brief. So IP interface brief. I have used the loopback 0. Okay, let's use the loopback 0. Okay, remote AS6500, update source, my loopback 0, address, family, L2, VPN, EVPN, and we send community both. Okay, that's all about the BGP, show run BGP. That's all I have to configure. I will establish a directory BGP pairing between a leaf switch in the real network. Let me do it one more time for the BGP. We configured BGP. Here and here. Inception BGP. Okay, this is establishing direct BGP pairing between leaf switches. But in the real network here, where I have more switches, I wouldn't do this. I wouldn't want to create BGP VPN between all the leaves. So this make more sense to configure the BGP router refactor on the spines. So this RR in real time, real life. Then establish between peer with route refactors only. So in real life, you will have BGP, BGP, and BGP, BGP in this way. So this configuration makes a solution more, much more scalable. Spine switches can actor route refactors. Just remember that. Of course, I have to do on my leaf 3 feature VN segment. You know, this to enable the VLAN mapping feature, VNI mapping, MV overlay, enable VXLAN, MV overlay EVPN, enable BGP EVPN, and I do the mapping 1000 to 200, 3000 to VLAN 201. So VLAN 200, VN segment 1000, exits VLAN, VLAN 201, VN segment 3000. Okay, so run VLAN. I have VLAN mapped to VNI, L2 VNI, show VXLAN. I have the mapping very clearly showing here. Now, so I loopback 1, and description will say VTAP. IP address for my leaf 3. Router OSPF underlay area IP ping sparse mode. Okay, let's show IP route 192.168.254.11. In underlay, I should have it. Yeah, I have it. Now we need one interface. How do I know? Make it VTAP. So okay, let's make a loopback one and my VTAP, right? So we're gonna do interface NVE1. So what's NVE? NVE stands network virtualization endpoint. That's VTAP interface. We're going to use loopback one interface as a source and configure BGP as a host reachability protocol. So no shut this interface. Source interface loopback one. That's my VTAP interface. Host reachability. We want a protocol BGP to replicate. Now we're going to show MVE interface. Show MVE interface. Take a look at here. Encapsulation VXLAN. Now, okay, loopback one becomes VXLAN encapsulated, and it shows me VPC VIP only, and it gets a MAC address in control point. Source IP is my loopback one. So interface should be up now, and now I have MV interface. I can add MVI to the interface. So how to do that? We're gonna enter MVE1 and member MVI 1000. See, we have 1000. How do we do this? 1000 and 2000. How do I use the multicast for replication to take care of the bomb traffic? Like we have to use a multicast. Amcast, we're gonna pick up a multicast group. Member, add a member is VNI L2, VNI 2000, and Amcast, we use the same multicast group. Okay, so we're gonna repeat all of that in leave 3. Same thing, we're gonna make sure the loopback 1. So run interface loopback 1. I have loopback 1 and it's VTAP. Interface MVE1 and make sure there's no shut, and make loopback 1 my VTAP interface, and host reachability protocol BGP, and this the configure BGP as a host reachability protocol to take care of the unicast, non-unicast. And we have to do is interface, okay, interface MVE1, go back to this interface, member MVI 1000. We have 1000 and 3000. So 1000 Amcast 239.0.0.1 access member MVI 3000, same Amcast. Show run interface MVI1. Okay, at this point I can see this mapped out. Show MVE interface. Okay, you can see the encapsulated VXLAN. Now let's go to my server 11, and I want to go to pin the server 12 and pin back also. So pin 192.116.100.21. One sec. Pin it one more time. Here you go. I can pin from server 11 to server 12. Let's go to server 12, and I'm pinging the server 11. They can ping. As you can see, there's a connectivity between the servers. Now we're gonna check something MVE peer. So we have to establish the tunnel, right? So this is a tunnel we have. So you can see the peer for MVE is up. If you don't see the peer, you have to save the config and reload it, then check it again. And we show MVE VNI, and these two we have, and leave, show MVE VNI, leave 3, I have them all VNI 1000 here mapped out to VLAN 100 and VLAN 200. So two VNIs are in the table, and both VNIs are up. The type is showing L2. I can also see the multicast group for the bomb traffic. IP here different because I'm using a primary IP. Don't worry about this for now. And I can see the MAC address of my server 12. And the next hop is a remote switch. I can also show L2 route, EVPN, MAC all. Here's my server 12. It's my primary IP, don't worry about this, and it's showing the BGP. Okay, I'll show you the address we have is here. Is the VTAP and is the MAC address 942F. Take a look. 942F, and it goes to my leaf 3 VTAP. 3 entries will be showing in the table. The table also shows how MAC address was learned. So the next hop IP and the VNI tags. And this is an entry for server 11 and 12. And I can see the server 11 is reachable through Ethernet 1/5 interface, and the server 12 is reachable through the VNI, through a VNI. And there's also entry for server 21 also, and this is local on Ethernet 1/6. Okay, let's verify that multicast routing table on leaf A show IPM route. I can see this entry that used for bomb traffic entry. This star, comma 239.001/32 shows because I have mapped my VNI to this V multicast group, show interface NV1. The ping automatically will create a two source tree entries that is PIM enhancements and optimize this distribution. For the next we'll take care of is to configure layer 3 VNI. We have successfully established the layer 2 VNIs in previous lab, and layer 2 VNIs are isolated island. When I wanted to provide connectivity between these subnets, one solution is to deploy an external router with an interface in all segments. So router then routes traffic between these segments A more scalable way is to use layer 3 VNI to route traffic between layer 2 VNIs, and it is similar to using SVIs on layer 3 switches to route the traffic between VLANs. So to do so, we have to create a L3 VNI, say 5000, and we create the VRF. It's gonna be a VRF, and we configure the SVI for host-facing VLAN routing and SVI for core-facing VXLAN routing. Then we map L3 VNI to an NVE interface. Then we have to enable the IPv4 address family for VRF under the BGP configuration. Now let's update my diagram. I have to configure VNI 5000 for all the L2 VNI to route the traffic. Let's go on to my server 11, and we would like to ping server 21 and server 22. The ping is unsuccessful. Both servers are connected to different L2 segments. The goal of the task is to establish connectivity between all these servers. Let's go to my leaf 1. We have to create a VRF called tenant 1 on leaf A and set VNI 5000. So run interface VLAN 100, 101, show run VRF, tenant 1. So these are all we have configured. We create SVI interface and let our use as a default gateway, in particular VLANs. So I should have connectivity to server 21 and 22. Now we should have able to ping 21 because we have gateway now. Later we have take care of phones 11 to 22. Now let's do the ping to server 21. At the server 11 ping. Okay, let me ping again. Ping 172.16.1.1. Ping. Let me ping the gateway. Okay. VLAN 101 gateways. Okay, let's do ping 11. Ping is successful. Go to 21 and I'm gonna ping 172.16.100.11. And I can ping its gateway also. Pretty cool. This traffic is routed locally on the switch. I have connectivity between these two servers. Now we can do is navigate to leaf 3 and we can configure VRF content tenant. We'll do one more time. Tenant 1 VNI 550.0.0.0 and RD auto address family IPv4, Unicast, route target, both auto, route target, both auto, EVPN. Let's end this. Now we can configure VLAN 201. VLAN 201. We're gonna put the interface to the VLAN VRF 1001 and set an IP address to gateway the 172.168.102.102.1/24. So take a look at how to do it. Interface VLAN 201. Interface VLAN 201. Sorry, feature interface VLAN. Then I can do interface VLAN 201 VRF member, right? 1001 IP address. Okay, no shut. This interface will be used as a gateway for server VLAN 201. Now, go to this server 22, and what I want to do, I want to ping the gateway first. Okay. Now, you can see the gateway is reachable. What to do, go to server 11, and we're going to ping 172.16.111, which is itself I did around. So let's go to server 22. At this time, I want to do a ping from its own IP to server 11. This is what I want to do. Okay. We're gonna ping 172.16.100.11 from server 22. Now you can see server is unreachable. Why is that? Let's check the routing table for VRF 1001 on leaf 3. Okay. Show IP routes VRF 1001. As you can see, the subnets for VLAN 100 and for VLAN 101 are unknown to leaf B. That means it doesn't have a route. So I must configure routing to successfully establish connectivity between these segments. What should I do? What I missed. So go to leaf 1. Okay. Have to create a VLAN 1000 on leaf 1 and map the VLAN to VNI 50,000. So what to do? So VLAN 100 VN segment 50,000 and show run VLAN 100. So that's my mistake. I'm going to associate VLAN 100. So it's not VLAN 100, VLAN 1000. We don't have VLAN 1000. I must create the VLAN and map it to VNI. So L3 VNI needs a SVI also. We needed to associate with a VLAN. So I have to create a VLAN and map it to VNI. So VLAN 1000 this time. VN 50,000. Okay. So show VXLAN. See, this time you wanted to see this VLAN associated to 1000, this VLAN associated to VNI 2000, and what VNI 1000. This is L2. Remember, this is L2. L2. This VNI associated to VNI L3 VNI 50,000. This VNI associated to 3 VNI 50,000. And we'll give it VLAN, right? We're going to VLAN 2000. We'll give it VLAN 1000. Okay. This is the deal. Configure VLAN 2000 VN 750,000. Show VXLAN. I want to show you the mapping, showing you L2 mapping, L3 mapping. 1000 to 50,000. Failed to associate with 2000 to 50,000. That's fine. Continue on leaf 1 and I will configure core facing SVI for VLAN that I have just created. Let's put the interface in the VRF tenant 1 and use IP forward command on the interface and disable redirects. So what this time we do, configure interface VLAN 1000 VRF member tenant 1 IP forward, no IP redirect, no shut, show run interface VLAN 1000. So I have created the SVI that is associated to the VRF. The IP forward command will enable IP forwarding on the interface, and it is used to allow IP traffic on the interface when there's no IP address configuration on the interface. Okay. On leaf 1, I have to associate VNI 50,000 and the NVE interface. This what I'll do. NVE1 show run NVE interface. NVE. We only have L2 VNI. We have to make a member VNI 50,000 associated to VRF. The attributes associated VRF is used to identify and separate processing VNIs that are associated with VRF and used for routing. Only one, I will create the route map that permits all traffic. So I name my route map permit all. And end it. A route map is required when I redistribute traffic into BGP. I will need this route map in the next step, and where I will redistribute directly connected routes in my BGP instance. So let's do it. Router BGP 6500 and also VRF tenant 1 address family IPv4 Unicast. We're going to redistribute direct route map, say permit all. We have already created. Let me erase all of this. We have created VLAN 1000 to this VNI 50,000, right? And this is a global setting for the, we have configured everything for the leaf 1. Now we have to define everything for the leaf 3. So first thing we will have to do on leaf 3 is to create this VLAN 1000, and we have to make associated mapping to 50,000. Show VXLAN. So VLAN 1000 is gonna map to VNI 50,000. Now let's refresh my diagram. This map has been created. Okay, so similarly, Similarly, we have to configure the core facing SVI on the leaf 3, and we use the same value as I used on the leaf 1. So we can go to VLAN interface. VLAN 1000 is L3. VNI associated VF will make a member tenant 1, IP forwarding, and no IP redirect. Make a forward, no shutdown. Last, enter MVE1 interface, MVE1 member MVI 50,000. We're gonna associate the VF. Show run interface MVE1. So we create run map, say permit all, and this create a route map that permits all traffic. We're gonna use the name permit all for the route map, and I will enable IPv4 address family in the VIF tenants under BGP instance. So that's saying we have to go to BGP and VIF instance tenant 1 and redistribute, and we enter IPv4 Unicast, and we redistribute direct route map permits all. Now let's show the table. Show IP routes VIF tenant 1. On leaf 3, I can see the route, these two routes. They're getting from VXLAN. The two routes showed in the routing table, and these two routes are announced via BGP, and the VNI 50,000 is used for forwarding traffic for these two subnets. And also we're going to show BGP L2 VPN, EVPN to confirm that. And the routes are under the L3 VNI 50,000. Now you can see the routes are announced in the layer 3 VNI 50,000. Okay. Go to server 22. We want to ping server 11. As showing, the ping is now successful. That means I have successfully configured routing between VNIs. Now let's go to leaf 1, and I can show MVE VNI that verify the VNIs. This confirm 50,000 is a tenant 3, tenant 1 as the L3. I can see additional entry now has shown, and the mode of this VNI is showing L3, and it is part of the VIF tenant 1. Now we have to configure Anycast gateway. I have configured the gateway. Remember, I configured the gateway .1 for the leaf A in the previous lab for VNI 1000. It is not optimal, as the traffic from server 21, 22, they have to go to leaf 1. They all have to go to leaf 1 to reach out to any hosts in VLAN 1000, then VLAN 1000, and you forward back to shelf. This is not optimal, okay? If you understand. On leaf 1, it is routed to layer 3 VNI, then forward back to leaf B. So the traffic goes to the gateway for VNI 1000 for all this. They have to go there, and will be forwarded by this. That's fine, and what not fine is I have to go this way. Okay, we forward back to leaf 3 from leaf 1. So in this task, I will configure Anycast gateway feature. It is default gateway addressing mechanism that enables me to use the same gateway IP address across all leaf switches that are part of the VXLAN network. So this feature will give me a flexibility to put workloads to any leaf switch. It allows host mobility and optimal traffic forwarding. We'll have to configure is a Anycast gateway for the VNI 1000 on leaf 1 and leaf 3. So server 11 and server 12 will all be utilized this Anycast gateway. Now let's show type up. Take a look at this up entry. This is what are we using. So let's see the up table. This entry for the default gateway in the up table, use the MAC address on the VLAN 100 interface. We can convert that. So show interface on leaf 1 VLAN 100. We'll say include address. Do you see this address? Last 4 digits, 1B08, 1B08. So this is what we receive for gateway on the server 11, right? So the gateway is on leaf 1, right? And the gateway is, I put it here, 1B08. And so rule 11 receives 1B08. Okay, for the gateway. That matches. Okay, change the configuration on the switch to use that configuration. Configure the MAC address for the Anycast gateway. It will be the same on both switch. Let's do one thing. I configure Anycast gateway MAC address on leaf A, and we're gonna use value 00011111111. How to do that? So fabric, what shows fabric forwarding Anycast gateway MAC 0001111.1111. Okay, type it in. And on leaf 1 interface VLAN 100, we're going to enable Anycast gateway forwarding mode for the VLAN 100 interface. So type in fabric forwarding mode Anycast gateway. So this is going to be my Anycast gateway. Similarly, go to leaf 3. We're going to configure the same Anycast MAC address on leaf B. Fabric forwarding Anycast gateway MAC 0001111.1111. On leaf 3, remember, this is using VLAN 200, okay? 200 interface, I'll make sure the parameters match once on leaf A under VLAN 100 interface. We did not configure this gateway. So we'll have to do this. On leaf 3, VLAN 200, VRF member tenant 1. say it's gonna say delete L3 configure on VLAN 200. We don't have address anyway. So IP address 172.16.100.1/24. Fabric forwarding mode Anycast gateway. No shot. Show run interface VLAN 200. Now we have it. Anycast gateway feature requires the same parameters on all routers. This condition will allow mobility and optimal traffic forwarding. So we have a gateway configured on the leaf 3, and leaf 1 already. This one configured. And we used the fabric MAC address, fabric forwarding Anycast gateway MAC address. That's 0.0.0.1.1.1.1.1.1. This is for this fabric forwarding Anycast gateway. To confirm that, we have to show IP route via F telnet 1. Now we have the gateway VLAN 200, and this is showing direct connect. Okay. Now show BGP-L2 VPN EVPN under my L3. What you can see is one for this 172.16.100 subnet. We have one phone local, one phone remote. You can see that two next hop for the subnet 172.16.100.0/24. One is local and the other one is announced from leaf 1. Now let's go to server 11, and we want to ping server. We want to ping from here to server, say server 22. Okay, ping 172.16.102.21. Okay, I can see it is still connectivity. There's still connectivity between the servers. Ping is okay. Ping is fine. Show up. Take a look at the MAC address. The gateway MAC address changed. You can see the switch is now the host is now using 000.111.111 as the MAC address for the gateway, and MAC address is same on all switches.
Hey everyone, NetMaven here. Don't forget to hit that subscribe button to dive into the world of amazing network technologies with me, and please feel free to leave your comments below. Hey everyone, NetMaven here. Don't forget to hit that subscribe button to dive into the world of amazing network technologies with me, and please feel free to leave your comments below.